As we move through the process, we now need to define all of the criteria for our slab on ground design. So in this opening screen, you'll see we have several different tabs, if you will: settings, structure, materials, and loads. So this video will cover the definitions in the settings section. I do personally recommend going through these in order from left to right, but in truth, you do not have to. So starting at the top, the design approach, Beckard SOG, is very common for much of the world. There are different regional options. For the United States, we'll use US BD 19 and ACI 318. This is going to bring in all of the IAPMO report definitions and standards that our designs are based on for here in the United States. System capacity, there are a few different options. This is, in its core, a yield line, an analytical tool. And so there are different approaches that we can use in determining the capacity of your slab on ground system. I do personally recommend using the design approach. It's the most straightforward and most common setting, though you can determine if you'd want to use the plain concrete section in the top and fiber section in the bottom. Fiber plus fiber, meaning the fiber capacity in the top and the fiber capacity in the bottom, or the maximum, which will determine of the various options just using the maximum. Again, I personally recommend the design approach. Next, we'll come to the country-dependent settings. For typical designs in most of the world, you can use standard settings. However, if you are in the United States, I do recommend changing this once again to just load in the remaining country-dependent settings that we use here. The concrete at age of loading, we only have the option of 28 days. This being the assumption that all of the loads that are applied to your slab section are done after full curing has occurred. Next, we'll get into the safety factors. So for those of us in the United States, you can think of this software is doing kind of like an LRFD approach, where we have material reduction factors or fee factors to reduce the capacity, as well as load factors to magnify the loads. So first, we'll start with the fee factors. The one which is potentially most new to you is the fee factor for SFRC. This stands for Steel Fiber Reinforced Concrete. The default value of 0.8 is what I recommend, and that is what is defined in our IAPMO report. However, if you wish to change it, you can use the sliding scale button here, or you can come into this field and simply write using your keyboard the value that you wish to use. You can always reset the value if you change it to something else. You can simply reset it to the default. For the concrete in compression, concrete in tension, and steel values, these are straight from ACI, so I personally recommend leaving these as is unless you have significant and compelling reason to change them. Continuing down, we get into the load factors. So again, using the LRFD reference, if you're used to, for example, a 1.2 times dead load plus 1.6 times live load combination, you'll notice here that the load factors are actually broken out differently. We don't have dead loads and live loads, but rather the type of load in its application. So rack or point loads, UDL, which is uniform distributed loads, line loads, and wheel loads. Additionally, there is an added dynamic factor for wheel loads if you wish to additionally magnify those moving loads. So you'll notice that there is a single load factor that you can apply based on the type of load. So whatever your overall load is that you want to consider from a factored or ultimate standpoint, you would enter an equivalent total load factor here, and then the ASD or service level load in the load entry screen when we get over here to this fourth tab. For the vast majority of designs that we do, the 1.2 factor is sufficient. Because we are not actually governed by ACI 318 or the IBC codes with those 1.2 dead and 1.6 live factors that I mentioned a moment ago. So in this case, you really are able to, as the designer, choose what load factor you want to use for any of these different loads. You're not governed by any code with a specific requirement if it is a true non-structural slab on ground. Again, you can use the slider to modify the value or enter it using your keyboard. Now, the fatigue safety factor. So if you're doing a project that has some fatigue considerations, perhaps a port pavement or something with continuous repetitive loading, you can enter the total repetitions that you want to consider between 100,000 and 10 million repetitions, as well as a fatigue safety factor between 1 and 2. In this particular example, I'll go ahead and turn this off. Next, in the center, you see an image showing a kind of quick representation of your project, knowing that we haven't defined the actual structure yet. We also see on the right-hand side an overall percentage utilization and results. But please note that we haven't entered any loads yet. These are pre-populated, so we'll have to update these as we go. In the next video, I'll look at setting up your structure.